Hi, my name is Mina and this is my presentation for Lab 3 Charge Tapes. Our purpose in this lab was to observe magnetic field in different orientations such as on or off axis. We also wanted to explore how magnetic field depends on distance and to demonstrate the beeyo law. We will use the principles of the beeyo law, magnetic dipoles, and distance dependence in this lab. And here's just a picture of a magnetic dipole with the magnetic field lines. So the main physics we used were, of course, the beeyo law, which is an equation for magnetic field by constant current, and it says that field is proportional to the current. We also used the principles of magnetic dipoles, which is a magnet with a north and south pole separated by a small distance. We also used distance dependence, which says that field strength and distance are inversely proportional. So as distance increases, field strength decreases. And we also use magnetic field lines, which are a continuous loop that flows perpendicular to surface and never cross. So here's just a brief introduction to my results. We predicted that the constant n would be negative, and we found that to be true. We also predicted that the value of k would be positive, and we found that the magnetic moment, mu, was 22.9 amperes per meter squared, and we found that field strength decreased as distance increased, and we also compensated for magnetic north in our experiment. So to set up our experiment, we set our magnetic dipole at varying distances and orientations from the magnetometer app on our phone. We used a meter stick to measure, and then we also used tape on our phone to locate the observation location on the phone. Some assumptions we made, these were given to us in the lab manual, and these were the ones that we used. So when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. And our system was the magnet and the meter stick, and our surroundings was everything else in the universe. So then we organized our data into an Excel spreadsheet so that we could plot it using a natural log plot. And as you can see, slope is negative. So the value of slope is our value of n, and the value of the intercept is our value for k. And then here are my calculations, the relationships and constants that I used, and the final value for mu, the magnetic. Yeah. And then in GlowScript, we were given a skeleton code to fill out with our vectors and our measurements. And then we are also required to write a function for calculating the magnetic field of the dipole. And here's that function here. And then here's the output of my code. And it just outputs the values that I already calculated by hand. So some possible sources of error to discuss. So we assume that the dipole approximation was constant, but it may not have been. And then we also didn't consider the magnetic interference from the surroundings, especially because we didn't do the experiment outside. There was a lot of interference from surrounding technology. And we are also unsure of the accuracy of the observation location measured on our phone. So these are just some things to consider when looking at our results. And just a brief summary of the findings. So as expected, the strength of the magnetic field decreased as distance increased. We were left with a plot of Ln that had a downward slope. We found mu to be 22.9 amperes per meter squared. And then from our plot, we found n to be negative 1.9. And we accurately predicted that n would be negative. And lastly, I'll just answer these two questions. So what if you hadn't oriented your experiment to compensate for magnetic north? So if you recall, we had to compensate for magnetic north so that we would get a near zero x component. So if we hadn't done that, our results would have been skewed in that direction. And the second question is, what if you were to stick two identical magnets together? So how would this affect the results? So the direction would remain the same, but the magnitude would increase by that much. And it would just be as if it were a stronger magnet. And that's it. Thank you.